Welcome to Summarize Science. What is the universe's fundamental, ground state, its most basic form? In quantum gravity, one of the most elegant candidates for this is called the Chern-Simons-Kodama, or CSK, state. This state is an exact solution to the equations of quantum gravity in a framework known as the Ustekar formulation. It perfectly describes a universe with accelerating expansion, known as de Sitter space, which is a good model for our own universe. However, for decades, the CSK state was plagued by a huge problem. In quantum mechanics, the probability of all possible outcomes must add up to 100%. But when calculated using standard methods, the CSK state gave a probability of infinity. This issue, called non-normalizability, made the state seem physically meaningless, like a beautiful but broken idea. This paper argues that the problem wasn't with the CSK state itself, but with the mathematical tools used to analyze it. The researchers show that a more appropriate tool, a holomorphic inner product, must be used, which is derived from the core principles of the theory. Think of it as using the right kind of ruler to measure a very strange and complex shape. Using this new, physically motivated ruler, they reanalyzed the state, looking at tiny quantum fluctuations on top of the de Sitter background, which represent gravitons. And they found a breakthrough. The state is perfectly normalizable and physically sensible, but only if the cosmological constant, the thing driving cosmic acceleration, is incredibly large. This is a fantastic proof of concept, but it doesn't quite match the small cosmological constant we observe in our universe. So, what about a universe like ours? For smaller values, the researchers found the state splits into a well-behaved part and a problematic, infinite part. To solve this, they propose a sophisticated mathematical procedure, a specialized Wick rotation, that can be applied only to the problematic parts of the calculation. This technique essentially rotates the bad numbers away, making the entire state normalizable for any value of the cosmological constant. So, let's recap the important points. The CSK state, once dismissed as a mathematical curiosity, has been shown to be a viable candidate for the wave function of our universe. The infinite probability problem was solved by using a more consistent mathematical framework. And a method was proposed to make the state work even for a universe with a small cosmological constant like ours. This work provides one of the first concrete examples of a normalizable, well-defined vacuum state in a non-perturbative quantum gravity framework. It opens up exciting new paths for exploring quantum cosmology and understanding the fundamental nature of our accelerating universe. Thanks for watching.